Okay, so we just talked about these steps to solve our rational equation. We're going to do it the simple way by clearing the fractions by multiplying through by the common denominator. We have to pay attention to those restricted values for the variable, and then we will solve what's left. So we already discussed this with number 1. If x happens to equal 0, that can't be an answer. Because if x were 0, this expression would be undefined. So x cannot equal 0. Now, in the past, I have called this the no-no box. Okay? That is not a mathematical term. That is a dumb name I made for it. Okay? So whatever we put in here cannot be the answer. It's a no-no. It cannot be the answer. So if we got to the bottom and solving this equation, and our answer was x equals 0, well, that's a no-no. We can't do that. X cannot equal 0 because at x, a value of 0 is a restricted value for this variable. So there'd be no solution. It's not no solution, but so we'll do it together now so you can see what it is. Okay, so when we have this equation, we have listed our restricted value. Now we're going to multiply everything through by the common denominator. So our denominators are 3x and 4. So our common denominator is 3x times 4. So every term gets multiplied by that common denominator. You could certainly write that as 12x if you wanted. Now I didn't, because the next thing I'm going to do is cancel. First of all, before we move on, is what I just did fair? Is that something you can do with an equation? Multiply both sides of the equation by exactly the same thing?
Yep.
Yes, it's still balanced. I multiplied both sides of the equation by exactly the same thing. All right, so now we're just going to cancel. This times this, well, this denominator will cancel with that numerator. This denominator will cancel with that numerator. And so I am left with 4 times x minus 2 on this side, and 1 times 3x on this side. Then we will distribute. And solve this very simple equation. I will move my variables to the other side and either multiply or divide by -1, and I get x equals 8. Okay. Was 8 a restricted value? No. So that is a solution. Now, let's check it. To check it, you could plug it back in. 8 minus 2 over 3 times 8. Does that equal 1/4? Well, 8 minus 2 is 6, and 3 times 8 is 24. Does 6 over 24 reduce to 1/4? Yes. I plugged 8 in for x. So 8 minus 2 is 6, and 3 times 8 is 24. And 6 over 24 does reduce to 1/4. Yes, sir.
Wait, so what did you do to get rid of the 4x and then the 3 after you distributed?
I just didn't show all my steps. I subtracted 4x.
Okay, I don't know if there's some other thing.
No. And then I did multiplied or divided by -1. Either way, it works. What now?
I thought it said times 2.
Okay. So what is the restricted value for x here? Well, what would make this denominator 0? 0. And this one, same thing. So once again, we only have one restricted value. X cannot be 0. And now we're going to multiply through by the common denominator. Very simple. I've got 4 and x. So the common denominator is 4x. So we'll go through and multiply every term by 4x times 4x times 4x times 4x. Moby's glitching. There we go. Okay, so on the first expression, the 4's cancel. On the second expression, the x's cancel. And on the third one, the x's cancel. Oh, this is a minus. What do we do with a minus, guys? We always change it to adding the opposite of everything in the numerator. We'll look at one in a minute that has a binomial, so you got to distribute that. This one doesn't. Okay, so what are we left with? We're left with a 3 times an x plus a negative 1 times a 4 equals a 2 times a 4. So 3x minus 4 equals 8. 3x equals 12. X is 4. Is that a restricted value? No. And you could plug it in to see if it works. 3/4 minus 1/4. Does that equal 2/4? Yes, it does. It checks. Okay. Oh, that's even easier. Yeah, everything cancels. All right, example 3. So, if we look at these denominators, this third expression will factor. And we need to factor it so that we can find the common denominator, just like we did when we added and subtracted. So the common denominator is x plus 2x minus 2. So what are the values for x that would make this first denominator 0? What could I plug in there that would make that 0? 2. Okay. What about here? Negative 2. So the restricted values for this problem are positive or negative 2. So if I get to the end and that's my only answer, there's no solution. If I have multiple answers and that's one of them, it's an extra answer. It's called an extraneous solution, which means it's an answer that we get when we solve algebraically, but it's not an answer to the problem. All right, so now we've got that set up. We need to go ahead and multiply each one of these by x minus 2x plus 2, x minus 2x plus 2, x minus 2x plus 2. And then we're going to cancel. So the x minus 2's cancel, the x plus 2's cancel, and everything cancels. Okay, so what are we left with here? We're left with x plus 3 times x plus 2 plus a negative 14 times x minus 2 equals 3x minus 2. You could leave that minus 14 because there's only one term there. But right here, there's multiple terms, so we must make a change there, right? Okay. So we're going to distribute, and we get x squared plus 3x plus 2x plus 6 when we distribute. And then here we get a negative 14x plus 28. All right, so we've got some like terms over here, so I'm just going to go ahead and add those up. 5 take away 14 is negative 9. 6 and 28 is 34. All right, there's a squared left, which means that this equation is a quadratic equation. Now hopefully it'll factor, because factoring is generally the easiest way to solve a quadratic equation. If we look at it and it doesn't look like it'll factor, then what do we have to use for a quadratic equation? The quadratic formula. That's right. This one does factor. When we move everything over, because we must set it equal to what? A quadratic equation must always equal 0 before we start solving. So we got to move this over, and we got to move that over. This one factors. It's real pretty. It's actually a perfect square trinomial. Yeah. So you can write it like this. If you noticed it's a perfect square trinomial, you could write it like this. If you didn't, they mean the same thing. Alright, so what value of x would make this equal 0? 6. Alright, is 6 a restricted value? No, so it is this solution. Alright, you try example 4. Don't forget to distribute this negative. Don't forget. Don't forget. Okay, so here's the solution to your U-try. This is the equation we should have ended up with. And when we solve, we should get 3. Our restricted values were -4 and 2. So 3 is a good answer. Okay, so we haven't had one where our answer created an issue. So that's what our last example is going to be. What happens when our answer, or part of our answer, is a restricted value? So that'll be our last problem. All right, any questions about number 4 as you look at it?
Why wouldn't the restricted values just be -4?
Well, because -4 makes the first expression undefined, but 2 makes the second expression and the third expression undefined. So we have to list any possible values for our variable that would cause any part of our equation to be undefined, because at that point the whole thing is undefined. Okay. Oh, last one. I'm running out of time. So you guys can just watch and you can grab this later. My restricted values are 0 and 2. So we got to multiply each one of them by x times x minus 2, x times x minus 2, x times x minus 2. Be still for a second, guys. This leaves us x equals 3 times x minus 2 plus 2, which is x equals 3x minus 6 plus 2. Negative 2x equals -4. X equals 2. But 2 is restricted, therefore there is no solution. Sometimes we get 2 answers, one of them works, the other is restricted. That happens too.